Hey everybody, welcome back. This is Mr. Laverick's Honors Algebra 2 class. Thank you for joining us here today. Don't forget to subscribe, hit the like button, comment below with any math problems that you want us to solve. I won't pay attention to that. All right. Okay, here we go. Okay, we're doing 2 days on section 6.5. Okay, 2 days on section 6.5. Now, what we're going to do today is very similar to what we did yesterday, but now we're applying it in a little different way. Okay, remember back in quadratics when we found the factors, and the factors found us the roots. And the roots were essentially the zeros, which means they were the x-intercepts, right? And we kind of talked a little bit about that yesterday, where if you somehow find the factors, you have found where it's going to cross the x-axis. And that's an extremely important piece when you go to graph. They're very important numbers. The x-intercepts, the zeros, the roots, whatever you want to call them, those are key values within the polynomial. Okay, so in lesson 6.4, we use several methods of factoring polynomials. As with quadratics, is everything factorable? No. Not everything is factorable. Okay? Same is true for polynomials. You know, think about a sum and difference of cubes that we learned yesterday. I mean, that's a very specific case. It's got to be a cubic binomial where they are both perfect cubes. Right? It's an extremely specific case. So, as with some quadratic equations, factoring polynomial is just one of the way to find the real roots, right? Okay, now we remember back, and this is what I was reminding you at the beginning just a second ago. The zero product property says that if you have found that if you have found the factors, you can set the factors equal to 0, and that will tell you the roots, right? So if you have a factor of x minus 3, x equals 3 is the x-intercept. If you've got a factor of x plus 4, then x equals negative 4 is your x-intercept. If you've got a factor of 2x minus 1, x equals 1/2 is your x-intercept, because you say 2x minus 1 equals 0, and then resolve, right? We know that. That's not too bad. Okay, so that being said, let's solve this polynomial by factoring. Okay? Let's solve this by factoring. 4x to the 6th plus 4x to the 5th minus 24x to the 4th. Okay. What's the first thing that you should always check? If I say solve this by factoring, what should I check? GCF. So we factor out a 4x to the 4th. Would you follow me there? So what's that leave us? That leaves us with an x squared plus x minus 6 equals 0. Keep factoring. What does that factor into? Factors a negative 6 that had to get to positive 1. 3 and negative 2. X plus 3, x minus 2. Don't forget about the 4x to the 4th sitting out there on the end, right? Still all equal to 0. Okay, is this fully factored down now? Yes. And so I say to you, once it's factored down, you can set those things equal to 0 and solve each little equation. 4x to the 4th equals 0, x plus 3 equals 0, x minus 2 equals 0. When I solve that, what do I get? 0 divided by 4 is 0. The 4th root of 0 is 0. I get x equals negative 3, x equals positive 2. So this crosses the x-axis 3 times. This equation has 3 roots. Okay, this equation has 3 roots. Does that make sense? This is very similar to what we did yesterday, right? Factor it down, then solve. Yes?
It doesn't matter in standard form.
Let's put it in standard form always at the very beginning. Yeah. Questions here? We good? Yeah. Oh, there's another one down there. I thought so. Ooh, this is a good one. We'll do this one together too. So the question we just had, should we put this into standard form? Yes, because it's got to be set equal to 0, right? We had that 0 product property. You've got to set it equal to 0. So x to the fourth minus 26x squared plus 25. Now, I'm going to teach you a method to solve this. Okay. Do you see how this starts with an x to the fourth, then drops down into an x squared? We haven't done, we haven't solved quartics like this. We've solved quadratics like this, where it's 3 terms. We've solved quadratic trinomials, but we have not solved quartic trinomials in the same way. But it's extremely similar. It's extremely similar. Watch what I'm going to do. I am going to create a new variable, just to simplify it in our minds a little bit. I'm going to create a new variable. Let's call it u. Okay, let's call it u. Cursive u. And I'm going to call u x squared. I'm going to introduce a variable. I'm going to say this u is x squared. Okay. What would this first term be then? U squared, right? Do you all agree with that? If x to the fourth is my first term, and x squared is u, then x to the fourth would be u squared. Minus 26u plus 25. Oh, isn't that a quadratic trinomial? Can't I factor this like the same way I did before? Factors of 25 that add to get to negative 26? Okay, that's u minus 25, u minus 1. Do we all agree with that? Okay, so I introduced a new variable. I better not answer this question in this new variable that I introduced. I better put back in my old variable. What do you see now? Yeah, I see 2 difference of squares. So we've got x minus 5, x plus 5, x minus 1, x plus 1. So now it's factored down. And now I say x equals 5, x equals negative 5, x equals 1, x equals negative 1. Yes, I would. That is a perfectly valid answer. I would also accept plus or minus 5 and plus or minus 1. That would have been fine as well. So this polynomial equation has 4 roots. Positive 5, negative 5, positive 1, negative 1. This polynomial crosses the x-axis 4 times. Questions about that? Yeah.
How do you know what to set the new variable coming up with u? Why did you set it to x second? Why wouldn't you set it to something else?
Because that's simplified. Whenever you have this technique of creating the new variable, you should only do that when it's a 4 to nothing. When it's a quartic trinomial.
So that's the only time it applies?
Yeah, you'll do this. This is actually a technique that you'll use a lot in calculus too. Basically what you're doing is you're creating a variable that kind of simplifies your life a little bit.
Okay, so it could be a variety of different things.
Right.
Whatever.
Yeah, this is like U substitution. That's like what it's called. It basically creates a new variable so that you could plug it in just to wrap your mind around what's going on. Right.
So for a quartic trinomial like this, you're always trying to get it down to a cubic trinomial?
A quadratic trinomial, yeah.
Sorry, you know what I meant.
Yeah, I know what you're saying. Yeah, yes. The goal is to get it down to a quadratic trinomial because we worked with a million of those. And we know what to do with that. So we get it down to a quadratic trinomial, factor it, then reintroduce my variable back in so that we can solve it. Does that make sense? Yeah. You'll do that again a couple times. All right, now, sometimes a polynomial equation has a factor that appears more than once. Right? Sometimes a polynomial will have a factor that appears more than once. This creates what's called a multiple root. A multiple root. For example, in 3x to the 5th plus 18, x to the 4th plus 27x to the 3rd equals 0. If I factor this down, I get x to the 3rd factored out, 3x to the 3rd factored out, and I get an x squared plus a 6x plus 9, right? You guys follow me there? Yeah, not 72, 27. So we get 3x to the third, x plus 3, x plus 3. Do you see how I have a multiple root of negative 3? Right? I have what's known as a double root. I have a double root at x equals negative 3. Not only that, do you see how I have 3x to the third? Like I would do this, right? 3x to the third equals 0. But is that it? Necessarily, is that completely factored out? Couldn't I have done this? Right? Isn't that writing the exact same thing? So couldn't I really have said this? I mean, we would never do that because that's like way too much, right? We could just take the third root of 0 and we're fine. But in essence, aren't I really having 3 of those roots? So whatever the power is, if you pull out a GCF with a power on x, the power is the multiplicity. The power is how many roots it has. So this actually not only has a double root at negative 3, but it has a triple root at 0. Okay, so what does that mean? Right? Like, okay, great, we know what a multiplicity is, but what does that mean? Well, that means things about the graph. Okay? Double roots and triple roots look different within the graph, and we'll look at that here in a second. So what is it? A multiplicity, you might want to write down the definition. The multiplicity of a root is the number of times that x minus r is a factor of the function, p of x. Honestly, it might be a good idea to write down an entire paragraph. That's really important stuff there. So the multiplicity of a root is the number of times it's a factor. Right? If it's there twice, it's a double root. If it's there 3 times, it's a triple root. And then we have multiplicity of 4, multiplicity of 5, multiplicity of 6, however many, you can go on forever. So what does that mean? Okay, if there's an even multiplicity, the graph will bounce off the x-axis at that point. The graph will bounce off the x-axis at that point. It will lie tangent to the x-axis at that point. So did you see how we had a double root at negative 3? Look what happens in the graph. It's bouncing off at negative 3. Now, that is for all even multiplicities. That is for even multiplicities. For odd multiplicities, the graph will bend through. You know how a cubic function bends at 0? Like if you think about the parent cubic, x to the third, it will bend through the x-axis. It will bend through the origin. Same thing here. This bends through the origin. Okay? What I mean by that is, take a look. Follow my pen up here. Everybody eyes up here real quick. It's going to go up, bend through, and then go back up. I exaggerated the bend there so you can see a little bit better. So a bend signifies an odd root. A bounce signifies an even root. Okay? There are going to be times where I'm going to start by giving you the function, the graph. And I'm going to say, okay, factor this down using the graph, just like I did yesterday. What's different from yesterday is that every time yesterday I had it cross through directly. Right? Just go straight through. That's a multiplicity of 1. That means that there was only one root there at that time. Okay, if it goes straight through, there's the multiplicity is 1. It only exists once there. If it bends through, it's at least a 3. The problem with this is if I introduce the graph first, Well, a bend just means it's odd, bigger than 1 odd. So is it a 3? Is it a 5? Is it a 7? I don't know. You have to start working with the function to see. Same thing with the bounce, right? It will bounce off, but that just means that it's even. Is it a 2? Is it a 4? Is it a 6? I don't know. You're going to have to start working with the function to see whether it's a 2, a 4, or a 6. Okay? So basically what I mean here is bouncing off is an even. Bending through is an odd, bigger than 1. If it goes straight through, then it's just 1. The multiplicity is just 1. Okay? Does anybody still need this slide here? Okay. Let's try this problem. Don't worry. On day 2 of these notes, I finished this. So it may look like, man, we got 2 more slides to do and we only got 10 minutes. Don't worry. Day 2, I just finished whatever I need to finish from today's notes. Identify the roots of the equation, state the multiplicity of the roots. Speaking of the roots, you know the Roots, the band, Jimmy Fallon, right? Did you know one time my wife and I got tickets to go see Jimmy Fallon? And it's like the tickets are free, but you got to like sign up for them real quick. So we got tickets to go see Jimmy Fallon, and then somehow we got in like the 3rd row, right? And we got seated all the way on the end, right by where the door that everybody comes through. And Questlove, the drummer, was walking by, and I was like, "Hey, Quest!" And I put my hand up, and he fist bumped me.
No way.
I've never washed my hands. All right. So identify the roots of the equation, state the multiplicity of each root. Now, the first thing I should do is to try to factor this. But the problem is, spoiler alert, this doesn't factor. Okay. So here's what we need to do. We need to go to our graphing calculator.
You guys are calculators a lot tonight. Okay.
And you need to graph this. I'm going to start here while you guys are getting them out. X to the 3rd plus 6x squared plus 12x plus 8.
Yeah, look at her.
You know, you're being recorded.
I
I know. People are going to be like, can I not sit by the computer? I don't want all my conversations to be recorded. You can't talk crap about anybody.
Oh no.
It will be recorded. You mean Lane Evans?
Lane Evans, the one and only.
Lane. Team Lane.
It's over, Jay.
On the video. It's over, Jay.
All right, here we go. So, does everybody see this graph? Anybody not see the graph on their calculator? Remember, zoom 6 if you don't see it. What do we see here? It's bending through somewhere, right? That's telling me that there's an odd multiplicity. Bigger than 1. There's an odd multiplicity at where that's hitting. So where does it look like it's hitting? -2. How can we assure that that's exactly at -2? Let's run it through synthetic division. We could also see it in the table, but I'm just saying. Let's run it through synthetic division. Okay? Now, we need to do synthetic division anyway because we're going to need to factor it down in a second. So we have a 1, a 6, a 12, and an 8. So 1, -2, a 4, a -8, a 4, a -8, and a 0. Okay, now, the root is -2. The factor that corresponds with -2, you know, this was x equals -2, right? So it's x plus 2. You follow me there? Yeah.
How do you know, like, because you put negatives in the box instead of like, just don't you want to put like the opposite or whatever?
That's the opposite of the factor. Remember? The opposite of the factor. Like if I set that equal to 0, I would get -2. Does that make sense? Okay, so we got -2 as my factor, or sorry, -2 is my root, so x plus 2 is my factor. And now what's left over? An x squared plus 4x plus 4. And now we factor that down. And hey, look at that. Okay, what's my root? I only have one root. What is it? It's -2 with a multiplicity of what? -2 with a multiplicity of 3. Let's try one more with the time remaining. Sorry, do we need to go back? Anybody need to go back on that? Yep.
It could be a YouTube intro.
A YouTube intro?
Yeah, maybe like an intro and an outro. We keep your outro too. That like there's like your Patreon page, you know, and like and you know like your merch store. Not a merch store. You should, like, check
Did I get merch?
Yes.
Somebody told me yesterday I should start vlogging.
Oh, yeah.
I said that.
Average vlogs. My life is a math teacher.
Yeah, you would double subscribers overnight.
Double. Oh, 80?
No, 96.
Are we good here?
100 subscribers.
Okay. Again, the first thing that you should always try to do is factor it down, right? Because what happens when there's a GCF, a 2x, leaving us with an x to the 4th plus 8x to the 3rd plus, what's 36 divided by 2? 18? 18x squared minus 27.
72?
What?
I heard 72.
You could try to factor by grouping, but spoiler alert,
Yeah.
doesn't work. Okay, now here's the deal. Watch here. You keep chipping away at the big polynomial that's not factored down yet, right? 2x has already been factored out. So go here. We want to keep chipping away at that. So let's plug that in. We've got an x to the 4th plus 8x cubed plus 18x squared minus 27. Ooh. I see it crossing twice. I see a bend. Okay, I see a bend, and then I see a straight through. Right? So that means I've got something with an odd multiplicity. It looks to be -3. And then I've got something with a multiplicity of 1. It looks like it's at 1. Would we all agree with that? Okay, so what do we want to go with? We've got two options here. You want to try the -3 or the +1? +1, sure. So I run the +1 through synthetic division. Oh, shoot. Look at what I did. Look at what I did. I forgot a 0.
Attention.
Sorry.
I'm taking away your math credentials.
My math credentials. My math dentures. That sounds like fake teeth, but only for math. My math dentures. X minus 1 is my factor that corresponds with x equals 1. And then we got x to the 3rd plus 9x squared plus 27x plus 27. Now, you would try to factor that down, but guess what? Spoiler alert, it doesn't work. So what should we try now? That might not help. -3. The other root that the other root that we saw. So x to the 3rd. Oh, whoops. 1, 9, 27, 27. All right, let's keep it going. 1, -3, 6, -18, 9, -27, 0. I've done it like a million times. It's not that fast. Okay, so we've got 2x, x minus 1, x plus 3, right? Because it was x equals -3. And then we got x squared plus 6x plus 9. Ooh, does that factor?
Yeah.
Yes, factors of 9 that add to get to 6. 3 and 3. So that means we get 2x, x minus 1, x plus 3, x plus 3, x plus 3. So we get x equals 0, x equals 1, and x equals -3. What's the multiplicity on 0? 1. Multiplicity on 1 is 1. Multiplicity on -3 is 3.
Oh, yeah.
3.
Thanks for watching.
Ladies and gentlemen, thank you for watching. Don't forget to hit the subscribe button. Hit the like button. Comment with anything you liked or disliked out of this video. I won't pay attention to it. Have a great day.
The notifications.
Have a great day.